Okay, our last lesson for this unit is on sinusoidal regression and figuring out the equation it's going to do. So the idea is with regression, just like any other regression we did, you need to go to your calculator, go to stat, enter your data in the list, whatever they give you, all your x and y values. You could plot those points, if you wanted to, set your window setting, draw those points. You'll see that it follows sort of a sine pattern, so it might look in terms of your graph. You might get points that do something like this when you plot your points, and then go to regression like we did before. The only thing different is you're going to pick sine regression, which is near the bottom of the list, and it'll give you the equation. The equation will be in this form here, and we'll talk about that more in a second. And then you can graph it, and it would draw your sine graph accordingly to whatever the data points are. So we're not going to go through how to do the regression. We've done that before, so you should be able to figure that out easy enough on your own. What I want to look at is, what does that equation mean? Once you do the regression and you get your A, B, C, and D values, we want to figure out what that means. Okay, so let's suppose we did a regression equation, and let's suppose we entered in a bunch of temperatures, monthly temperatures for Leduc. So let's suppose we, in January, so we'll do January, so let's suppose it starts at like minus 20. So let's suppose it's something like that. And let's suppose February gets a little bit warmer, and March is a little bit warmer yet, April almost zero, May we're in the pluses by now, and June it's getting pretty warm, and July we're sort of going to hit 5, 10, 15, 20, 25, 30. Let's suppose we get up to close to 30 degrees by the time we hit June. In July, August will start to get a little bit cooler, so let's suppose it's about there. September is going to drop, October, November, and December. So let's suppose those happen to be our points that were given to us in terms of months of the year and the temperatures that they are. Okay, so you plotted those points, you could graph them on your calculator, then go to your regression equation and it'll draw the regression. Okay, so once you do your regression formula on your calculator and draw the graph, it's going to make this into a sine graph. So it might look something like that. Even if the points don't line up, remember that's the whole point of regression. It's going to do the best it can for the points and draw the best kind of curve that fits. So even like I said, in my diagram the points are off, but whatever, close enough. Okay, so then let's suppose on your calculator it gave you a regression equation of, let's suppose it was 25. I'm going to make up numbers here a little bit, but that's close enough. So let's suppose it was 25 sine 0.5 x minus 2 and plus 5. Okay, so let's suppose that was the equation that we got from the regression calculation based on this graph and these points. So now the trick is, what do these points mean? So remember, on the last page, our calculator equation is going to be a sine bx plus c, and then plus d at the end. So these a, b, c, d numbers are actually important in terms of what's happening with the graph. So let's kind of go through each one and figure out what it means. So the first one we're going to start with is the d number. So in this case there, d was plus 5. So if you actually look on the graph and see where the plus 5 is, if we draw our line at plus 5, that looks like it's the midline. It's what's cutting that graph in half between minus 20 and 30. If we divide those in two, at plus 5 is halfway in between, so that would be our midline. So in our equation, d is the midline. Okay, so that's an easy one. Whatever that last number is, that's going to be the middle of the graph. The next one we'll look at is the a number. So in this case, a is 25, and a is an easy one to remember because it starts with a. It is the amplitude. So in this case, the distance from our midline to our peak, so from +5 to +30, we get an amplitude of 25. So that's a good one. The last one, or the last two numbers, they're a little bit more difficult to figure out. And the first one we're going to look at is the B number, the 0.5. And that one it's not really an obvious choice, but it has to do with the period. And if we actually take the period and we go 2 pi divided by b, that'll give us what the period is. And the reason why we have to go the 2 pi, if you think back to when we first started, one complete cycle in a circle was 2 pi radians. And because our calculator is giving us these numbers in terms of radians, we have to convert it back to just regular numbers. So a half a radian, we go 2 pi divided by half, we'll actually get, like 2 times pi is 2 times 3.14, so around 6. 6 divided by half would actually give us about 12. So in this case, we're getting a period of 12. So that means from start to the graph, we're getting a period of 12. And in this case, the context of the question makes sense because we did the monthly temperatures from January to December. So that means by the time we go January back to January, we have gone 12 months. So it makes sense that our period is 12 in this case. The last one, the C number, the good news is you don't have to worry about it. It has nothing to do with what we're worried about. All the C number does, and just in case you're interested, is the C tells us how much of a horizontal shift there is. So just like midline, right, and in this graph our midline was at 5, so our graph got shifted upwards. The C number would actually tell us how much this graph, so you can kind of see from a normal sine graph, it actually got moved over a little bit. So that -2 is telling us it gets shifted one way or the other in terms of the equation. So the good news is we don't need it. We need that number in order to draw the proper graph, but in terms of figuring out what's going on with the equation and the graph, it's not important. So the only three that you're going to work on in the equation is your A, B, and D numbers, which is your amplitude, midline, and the B will give you the period. Okay, so let's just go through a couple quick examples so you get the hang of it, and then that'll be it. So this first equation that I got, 3 sine x minus 2, if we were to sketch it out, we know that because it's at -2, that's our midline. So we know that -2 is going to be the middle of our graph. And we know our A number is 3, so that means that's our amplitude. So that means our graph is, let's suppose it starts at the -2. It means we'd go up 3 units and then back down 3 units as well. So we know that we're going to go from +1 down to -5 would be our maximum and minimum values. And the tricky one in this case is our period. So because it's just sine of x, our B number is 1. So our period, we can do the formula in reverse. You can go period would be 2 pi divided by B. So 2 pi is roughly 6, divided by 1 would be about 6, a little bit over 6. So that means in our graph, when we get to 6, we're going to basically be making one complete cycle. So let's sketch this one in. If we start at the -2, right at our midline, we know that in 6 we're going to make one cycle, so halfway at 3 would be back to the same spot, and then back at 6 would be back to the same spot again. And we know that it's got to go up to 1 and down to -5 based on the amplitude, and that would be it. There's our one complete revolution for this graph. Let's do one more. So if I gave you, let's suppose we have an amplitude of 2 this time, and let's change our B number to 3, and we can even put in a plus or minus on there, that won't really matter too much. And let's do an amplitude of 4 this time. Or sorry, a midline of 4 and an amplitude of 2. So if we were to sketch that one, we know that the midline is at 4. So that'll be our middle of the graph. We know our amplitude's at 2, so that means we're going up 2 and down 2. So that'll be our maximum and our minimum locations. And now the tricky one this time is our period is 3, so our B number our b number is 3, so we know our period then would be 2 pi divided by 3. So 2 pi is roughly 6, so that means our period is going to be 6 divided by 3, which is 2. So that means in this time, in 2, we're going to have one complete cycle. So assuming that our graph, let's just say it's going to start again at the origin. Actually, the plus 1 is going to make it shift over, but we'll ignore that. That's not important. So let's suppose our graph starts at the origin. We know we're going to go up to 2 up, back to our midline, 2 down, and we'd be back to roughly a period of 2, and then we could draw another one of those up, 1 and down again, and that would be it. Okay, so the key idea with this equation is making sure you can understand what do the ABC numbers have to do with the equation, and how that relates to period, amplitude, and midline in terms of the graphs. So that's it. What I'm going to do is I'm going to attach a worksheet, but it's actually an old quiz, so I want you to work on that as practice for the entire unit, and that'll be all.